Episode 3. The Quest for Sunspot Dynamics. Sunspots observed on the solar surface consist of two parts, a central dark umbra and a brighter halo surrounding it called the penumbra. The existence of gas motions in the penumbra of sunspots was discovered by British astronomer John Evershed more than a century ago. John Evershed and his wife Mary Evershed, also an astronomer, spent most of their scientific careers at the Kodaikanal Observatory in India. John worked as an industrial chemist, but he enjoyed observing the sun since his childhood. Indeed, a solar eclipse changed his life, and Mary's. A few eclipses later, John and Mary got married in 1906. That same year, he was appointed as assistant astronomer at Kodaikanal Observatory. The Eversheds were very active studying the sun, in particular sunspots and prominences. But the big achievement of John Evershed's scientific career was the discovery of the Evershed effect. To understand this effect, we need to recall a couple of basic concepts from our physics classes, without equations. Think about the sound of an ambulance passing you by. A sound wave emitted by a source moving towards us is compressed. A wave emitted by a source moving away from us gets stretched out. This frequency change is known as the Doppler effect. It makes us hear different pitches in the sound. Light waves also experience the Doppler effect. Gas moving towards the observer produces spectral lines shifted to the blue. Gas moving away produces lines shifted to the red. Evershed carefully measured the position of spectral lines in sunspots. He found them to be blue shifted on the side of the penumbra facing the observer, and red shifted on the opposite side. Evershed used the Doppler effect to explain what he had observed, and so he discovered the existence of gas motions in the penumbra. Today we call them Evershed flows. These motions are horizontal and follow the filaments that make up the penumbra. Sometimes they get supersonic, reaching speeds of 10 kilometers per second or more. But there are still many open questions. Why do they occur? How are they related to the penumbral magnetic field? Where does the gas go? To answer these questions, we need instruments capable of measuring magnetic fields and flows on the sun with unprecedented accuracy. The European Solar Telescope is equipped with several spectrographs working together to provide those kinds of measurements. Finally, we will be able to understand Evershed flows after more than 100 years of observations and theoretical interpretations.